Alright, so today we're going to talk about something that you may have learned before, and that is the concept of the greatest common factor. Now, most of the time when we think of greatest common factor, what we really think about is, and we break it apart, greatest common factor, is start with a factor. A factor is a number that goes into another number evenly. Like 2 goes into 8 evenly. So we'd say 2 is a factor of 8. So that's what we mean by a factor. So we're looking for a number that's going to go into 2 or more numbers evenly. Or a number that goes into another number evenly is a factor. When we're talking about a common factor, we're talking about a number that'll go into 2 or more numbers evenly. Like 2 will go into both 8 and 16 evenly. And that's when it would be a common factor to 2 different numbers. Now, the big one is when we talk about the greatest common factor. So we're looking for the largest number that will go into 2 or more numbers evenly. Most probably when you've learned this before, you were told to take the numbers, and let's say we use 12 and 18. And I want to find the greatest common factor of 12 and 18. You probably learned to start with list all the factors of each of the numbers. So you list all the factors of 12. So I know 1 is a factor, 2 is a factor, 3 is a factor, 4 is a factor, 6 is a factor, and 12 is a factor. When I look at 18, I know 1 is a factor, 2 is a factor, 3 is a factor, 6 is a factor, 9 is a factor, and 18 is a factor. Those are all the numbers that go into those two numbers evenly. When I'm talking about common, they both have a 1 in common, they have a 2 in common, they have a 3 in common, they have a 6 in common. But when I want to know what the greatest common factor is, well, the greatest common factor obviously would be 6. Now, that's how you probably learned how to do this problem. The thing is, that could take a long time if I gave you numbers like 144 and 238. You're not going to list all the factors of those. So what we try to do is look for a better way. And as always, I have a better way. Let's go back to 12 and 18. 12 and 18, what we're going to do is instead of listing the factors, I'm going to do what's called a prime factorization. Now hopefully you know what a prime factorization is, but if you don't, it's where you take the number and you break it down into its prime numbers. So 12 is 2 times 2 times 3. And what I do is from smallest to largest, I'm going to list all of the factors. 2 times 2, but I'm going to leave a space between the 2 and the 3. That will become evident later why I'm leaving that space. 18, if I need to factor that out, well, that's 2 and 9, and 2 is prime, and 9 is 3 and 3. So this is going to be 2 times, and what I'm going to do is I'm going to line up common factors. So I'm going to put the 2 under the 2. I'm going to put a 3 under the 3 and then times 3. And then what I do is simple. I make columns. And then I look for my GCF. My greatest common factor is I'm looking at all of the columns that are full. So I look at the first column. Is the first column full? Yes, it is, because it's got 2's at every level. But is the second column full? No, second column's not full. How about the third column? that is full because it's full of 3's, and the last column isn't. So all I'm going to do is multiply those together, and when I multiply 2 and 3, I find out that, again, my greatest common factor is, in fact, 6. Let's look at another one of these. What if I used 24 and, 32, just for the fun of it? If I was to prime factor 24, you would find out that that's 2 times 2 times 2 times 3. Again, leaving the extra space there. When I do 32, oh, no, you know what? Stop. Back that up. Wrong thing. No, hold on. Sorry. I was right. That's 8 times 3. This is 8 times 4. So it's 2 times 2 times 2 times 2 times 2. There is the greatest. That's how you factor 32. Sorry, lost track of that. So now I'll make my columns. Notice I left that space there because the 2's needed a place to go and not lining up with the 3's. So when I do this now and I write my greatest common factor, I have a 2, a 2, a 2, not full, not full, not full. So I find out that my greatest common factor is, in fact, 8. So again, I'm sorry I blew the multiplication there for a second, but 24 is 2 times 2 times 2 times 3, and 32 is 2 times 2 times 2 times 2, which gives me 3 2's. 3 columns are full with 2's, so I multiply those 2's together and I get 8. All right, let me give you one to try. How about you try 28 and, no, I don't want to do that one. Let's do 28 and 42. That works. Would you find the greatest common factor of 28 and 42? Pause the recording and see what you come up with. All right. If you did this correctly, you would have told me that 28 was 2 times 2 times 7. You would have told me 42 was 2 times 3 times 7. You would have made your columns, and you would have said the greatest common factor was 2 times 7, or 14. So the greatest common factor was 14. Did you get that right? Good. Now, why is this method better than any other method that's out there? Why would I even show you this method? Well, when we get to algebra level, you start getting numbers like this. 15x squared y cubed and 20x y to the fourth. Nothing's different here. Everything's the same. You just have to figure out how to factor the variables down. I want you to try this one. See if you could figure this one out. Pause the recording and work on this. Okay, if you did this right, you would have told me that 15 was 3 times 5 times x times x times y times y times y. You would have told me 20 is 2 times 2 times 5 times x times y times y times y times y. Make my columns. And my greatest common factor would be 5x, y, 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 or 5x, y cubed. Now, how many of you got that correct? Awesome. Here's the one I'm going to leave you with tonight. I'm going to leave you with trying this one. I want you to find the greatest common factor of 12x squared y squared, 18x cubed y to the fourth, and 24x y to the third power. No difference except there are 3 numbers here. Just be careful. See if you can figure this out, and I'll see you in the morning.